the weather forecast and wondered why it feels so generic? You see a prediction for your whole region, but what you really need to know is what's happening right in your city or even your neighborhood. This is a huge challenge in climate science. Traditional climate models are incredibly powerful, but they operate on a massive scale. Imagine trying to see the details of a single street on a map that only shows entire countries. These models often work with data points that are 100 kilometers apart. That's great for understanding global trends, but it's not very helpful when you need to predict if a specific city will flood or if a particular farming valley will face a drought. It's like trying to thread a needle while wearing boxing gloves. For years, this gap between large-scale data and local needs has been a major hurdle for city planners, farmers, and emergency responders. But what if we could zoom in? What if we could take that blurry 100-kilometer view and sharpen it into a crystal-clear 10-kilometer picture? This is where generative AI is changing the game. Think of it as a super-powered magnifying glass for climate data. Scientists are now using a technique called downscaling, where AI algorithms learn the complex relationships between large-scale weather patterns and local conditions. The AI is trained on massive datasets, everything from historical weather records to satellite imagery and sensor readings. It learns how mountains, coastlines, and even cities themselves influence the weather on a micro level. By understanding these intricate patterns, the AI can then generate incredibly detailed and accurate local forecasts. It's a revolutionary leap forward, transforming our ability to see the future of our climate. So how does this actually work? At its core, generative AI uses deep learning to process and interpret vast amounts of information far faster than any human could. It sifts through complex atmospheric data, ocean currents, and land surface details to create high-resolution simulations of what's to come. Instead of taking months to run a single detailed simulation on a supercomputer, AI can generate reliable local environmental risk assessments in a fraction of the time. This speed and efficiency are game changers. For the first time, we can get timely, actionable intelligence about local climate risks. The real-world impact is profound. With these hyper-local predictions, farmers can optimize their planting and irrigation schedules to protect their crops from a sudden heat wave or unexpected frost. City planners can design better drainage systems to prevent flooding and manage water resources more effectively. Emergency services can get early warnings about where and when extreme weather events are most likely to hit, allowing them to evacuate communities and save lives. This isn't just about better weather forecasts. It's about building a more resilient future for everyone. By harnessing the power of AI, we are turning data into decisions and empowering communities to adapt and thrive in a changing world. It's a powerful example of how technology can help us solve some of our biggest challenges. Thanks for watching. And don't forget to subscribe to the channel KnowHub for more insights into the future of science and technology.